Okay, good morning, class. So today we're looking at probability, grade 8 probability. You guys in grade 8 probability class. Okay. I'm just going to go through these topics. Yesterday we started our notes on probability. We spoke about experiment, sample space. What else did we speak about? Sorry? The what? Events? No? What else did we speak about? Theoretical probability, empirical, and all of those things. Okay. So let's look at the examples. We'll just read through a couple of things that we said here. We're looking at the example. This is examples for exercise. Should be 1. Exercise 1, and that is on page. What page is that on, people? Sorry? 313. Example 1 is on page 313. Okay. So we said relative frequency. Relative frequency of an event happening is the number of times an event occurring in relation to the number of trials done. We can represent this as a fraction, and we wrote this information with this fraction down. Not so? We said the number of times the event happens over the total number of trials. Then theoretical probability. What do we say about theoretical probability? That's pure probability. Okay? And this is the calculation that we will be using, or the formula we will be using most of the time. If not, yeah, most of the time. Okay. So the probability scale, this is also what we made notes of yesterday. Quite a bit of information here. Then we spoke about 2 coins being tossed and all of those things. And we explained how that actually works, the probability of getting, okay, so that is right there. They're talking about Smarties there, since the number of favorable outcomes, right? So then we wrote this down here as well. Not so? So we said if something is, remember that the probability scale is between 0 and 1. Okay, 0% and 100%. There's no we normally write it, okay? So in the probability scale, 0 is impossible for something to happen, right? Whilst certain is 100% or 1, okay? And then 50-50 is 0.5 or 50%, okay? Low chance or unlikely to happen is lying lower than 0.5, and if it's more than 0.5, of course, the chances of it happening is becoming greater and greater as it approaches 1. Okay, and that's a scale we wrote down yesterday as well. All the probabilities are expressed as fractions, decimals or percentages. I spoke about decimals and percentages earlier. Could be written as fractions as well. So if we're looking at 0.3, can be written as 3/10. You understand? But also note that we always write it in simplified version. So we don't leave it as 6/10. It becomes 3/5. You guys understand? We always write it in the simpler form. Okay. So here we are told that all probabilities are expressed as fractions, decimals or percentages. If there is a high chance of event happening, the probability will lie between 0.5 and 1. Okay? If there is a low chance of event happening, the probability will lie between 0 and 0.5. If there is an event or if there is an even or 50-50 chance of an event happening, the probability will be 0.5. Okay. If there is no chance of event happening, the probability will be 0. If there is if the event always happens, the probability will be 1. Okay. In the following exercise, you will be required to assign a probability value in decimal form to give the event. Not everyone will assign the same value to the event unless the event is certain, impossible, or even chance event. Have fun in this exercise. Then again, we always have fun, not so?
Yes.
Yeah. Okay, so they had a little exercise there. And it was exercise. Oh, I think I got it here. Yep. So let's do this together. Okay. It's actually EX. With a marking already. Right, probability. Exercise 1. On page exercise 1 is on page 313. Okay, I know you don't get odd letters, but I just put there instead of putting alternate. I'll just put that there. Okay. For each of the following events, assign the probability decimal. Right, remember we're going to go between 0 and 1. And we're going to use that scale that you guys have written down yesterday. Okay. So exercise 1. For each of the following events, assign a probability decimal. A. The probability of getting 2 tails if 2 coins are tossed at the same time. 0.5. How do you get that? You say 0.5, 0. What did you say?
0.5.
Yeah. So okay. So she says it's going to be 50-50. You all agree with that? Who disagree? What do you say it should be? If you're looking at the scale, let's just draw the scale. Let's put 0.5. This was 0.25, 0.7. Where do you think that will fit on the scale? I'm just going to rather get the scale quickly. It's a link now to everything. Right. So she says 0.5, which means to say it's a 50% chance. That's basically what she's saying, not so? So, do you all agree with that? Huh? No. Why? You see, if it's 50% chance, it's either that or something different. Yes.
So is it because like there's two points and like there's 2 points?
Okay, firstly, how many outcomes are there? There are 4 outcomes. It could be either heads, tails, tails, heads, tails, tails. There are 4 outcomes. How many of, if you go heads, what is it? Tails, tails, no?
Yes, sir.
If it goes tails, tails, how many of that 4 can be considered? Only 1. The tails, tails one. So it's 1 out of 4 chance. So 1 out of 4 is where we on the scale? 0.25. Can you see that, people? Alright. So that answer should be 0.25 chance. Okay. Is it confusing? No. Okay. Let's look at B. Oh, sorry, not B, C. C says the probability of getting a heads and a tails if the two coins are tossed at the same time. Remember, what are my outcomes? Heads, 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 tails, tails, heads, tails, tails. It says the probability of getting a heads and a tails. So it could either be heads, tails, or tails, heads. So what is that going to be? 2 out of 4. And 2 out of 4 is the same as half, which is the same as 0.5. You guys understand? Simple, no? A, B, C, E. Always gonna miss this. The letters up. E. The probability of a man falling pregnant in today's life, and it, I don't know, no? But where I come from, the chance of a man falling pregnant? 0%. Or impossible. For now, no? But you guys, you're a different breed. No? Alright. That's E. G. G says the probability of the President of South Africa visiting you at home. He didn't call him himself your uncle. Huh? 0. He doesn't come to Mitchell's Plain. Yes. Right. The probability of you winning the lotto, if you forget about it. 0. How you get 0.1? 0. You won't. People the lottery is haram, no? Yes. Yeah. K. K. The probability of an alien being abducting you one night. 0. What's wrong with the aliens here? M. The probability of a beetle playing for Barcelona. Okay. O. Probability of a boy surviving if he jumps out of an aeroplane without using a parachute.
0.
He's gonna die. Probability that all human beings will die. The probability that all human beings will die. 1. How is 0.1? Isn't it definite that everybody is going to die? Yeah. The probability that all human beings will die. Is 1. It's definite. No? Unless one of you are immortal, no? Okay. The world is not such a great place. Right. S. The probability of winning a prize in the competition. If 100 people entered. Okay. If you are the only person who entered the competition, what's the chance of you winning?
1.
Certain. If 2 people entered, 50. It was between you and that person. 3 people? 1 over 3. You have 1 in 3 chance of winning. If it's 10 people, 1 out of 10 chance that you will win. Because everybody has a chance to win. Not so. If it's 100 people, you have 1 in 100 chance of winning. 1 in 100 or 0.0. Do you guys understand? For homework, I would like you guys to do exercise 1. The other sums, no? Not the even ones, the other sums. Okay. So it's based on net. Alright, so that is exercise 1. The full lesson can be found in the description box below.